Hello, ladies and gentlemen. Today's video is going to be not about geometry, but about trigonometry and the three basic ratios. We named them in the Intro to Trig video, and those are sine, cosine, and tangent, but now we're going to talk more about what those relationships mean in regards to a right triangle. So what you're going to need is a pen, pencil, your foldable, or notes. If you don't have a foldable, that's fine. Just directly put it into your notes, and maybe a calculator. So if you have that foldable, that green foldable, this is what it should look like. And if you don't know how to fold it, you're going to fold on the solid lines and then cut on the dotted lines. And before we open it up and move on to some examples on the inside, I want to write on the outside. So you can see in the right panel, right here, that says SOHCAHTOA. I want to talk about what that means. So first we're going to look at the sine flap. So sine of theta is equal to the opposite side of the triangle over the hypotenuse. So theta, this is the symbol theta, and it represents an angle or any angle. So we're going to look at an example of what it would look like if we had a particular angle in mind, but right now we don't. So remember from our trig introduction video, we talked about how sine, cosine, and tangent are all different kinds of relationships between two sides in a triangle. So the two sides that we're talking about in the sine of theta is the opposite side. So if theta, let's say theta was this little angle here, the opposite side would be this side, and the hypotenuse would be this side, right? So we're saying that if we had real values, we're setting it up as opposite over hypotenuse. And then cosine theta is going to be equal to adjacent over hypotenuse. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. So in regards to the angle theta, the side that is adjacent to it and the hypotenuse of that right triangle, that's the relationship we're talking about. So make sure you're getting these little relationships on the front of your foldable. And then tangent theta is equal to the opposite side over the adjacent side, again, all in relation to theta. So we'll talk about, when we open this foldable, we'll talk about how to set these up. Okay, so remembering that these relationships, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent for sine, cosine, and tangent. Let's flip on the inside and look at how we're going to set this up. So we have to find the sine of angle A. So instead of a theta here, notice that this is angle A. So we're saying in relation to the angle A, we want to write the relationship or the fraction to set up. So it's opposite. So opposite of angle A is 6 over the hypotenuse of that triangle is 10. And if we reduce that, that's going to give us 3/5. So I'm going to use a different color here to show that we're now looking at angle B, the sine of B. So the sine relationship in regards to the angle B. Now the angle across from angle B, or the side length across from angle B, is 8 over the hypotenuse, which is 10. So if we reduce that fraction, that gives me 4/5. And we can see now that it sine in regards to a different angle makes a big difference, right? Sine in regards to the angle B gave us 4/5, but sine in regards to the angle A gave us 3/5. So you have to make sure you know which angle you're talking about in order to set up the relationship. So let's fill in the rest of this side of the foldable, the left side of the foldable. So let's look at cosine of angle A. So we're looking at cosine in relation to this angle A. So the side that is adjacent, remember cosine is adjacent over hypotenuse, so the side adjacent to angle A is 16 over the hypotenuse, which is 20. So if we reduce that fraction, we get 4/5. I'm going to take my blue pen now and look at cosine in relation to angle B. The side adjacent to the angle B is 12 over the hypotenuse, which is 20, and if we reduce that fraction, that gives us 3/5. Moving on to tangent. Okay, tangent in relation to angle A is going to be opposite of the angle A, that side is 15, over the adjacent side and the non-hypotenuse adjacent side, which is 20. We're not talking about the hypotenuse here. So the two numbers that we're going to talk about are 15 and 20. And when we're talking about tangent in regards to angle A, then that's going to be 15 over 20, which reduces down to 3/4. And if we're talking about tangent in regards to angle B, that's going to flip-flop, right? Now the opposite side is 20 and the adjacent side is 15. So now I'm going to have 4/3 instead. So make sure we understand those relationships in regards to the correct angle, whether we're looking at the acute angle, angle A, or the acute angle, angle B. Okay, so now we're going to use sine, cosine, and tangent to find missing side lengths. So we have to set up the ratio that we just talked about. So this is the first flap on sine. So we're going to be using the sine relationship, and we need to find the side lengths BC and AC. So first I'm going to do sine of the angle 21 is equal to the opposite side of the angle of 21 is AC all over the hypotenuse 9. So now I need to solve for that side AC. In order to get AC alone, I have to multiply both sides by 9, and this is where your calculator comes in. AC over 9 times 9 is going to cancel those two 9s. So now I have to punch into my calculator 9 times the sine of 21. And so when you punch that into your calculator, you should get a decimal of 3.2253. And I just want to tell you guys, from here on out, we're going to round to 4 decimal places, especially with trig. We're going to always round to 4 decimal places, so keep that in mind. Now we need to find the side BC. In order to do BC over 9, the opposite side over the hypotenuse, that means I have to take sine of the other angle, 69 degrees, in order to find that. So we have to multiply both sides by 9, just like we did in the one up top. And now we're plugging that into my calculator, 9 times the sine of 69, and we're going to get BC is approximately the decimal 8.4022. So that's how we're going to set up these two equations. We have to look at it in reference to the correct angle. We can't just stick with angle 21. We had to find the other angle. So 180 minus 90 minus 21 is 69, and we had to use that to find the other side length. Moving on to cosine, so make sure that you get in here that angle A is 53 degrees because 180 minus 90 minus 37 is 53. So we're going to have to set up the first one. I'm going to use my first angle as the cosine of angle 37. So the cosine of angle 37, remember cosine is the two sides adjacent over hypotenuse. So the adjacent side to angle 37 degrees is BC over the hypotenuse of 13. So we're going to take 13 times the cosine of 37, right, to get my side length of BC. So punch that into your calculator, 13 times the cosine of 37. We should be getting BC is approximately 10.3823. So make sure we round to 4 decimal places, and now we can set up our other one. Now I'm going to do the cosine from the reference angle 53 in order to get the adjacent side AB over the hypotenuse 13. So again, multiply both sides by 13, multiply by 13. AB is going to be approximately 7.8236. So make sure you get these two answers in your notes. Last but not least, let's do the tangent flap. We are finding AB and AC. So I'm going to first just look at tangent in reference to the angle 50 degrees. And remember that tangent is opposite. So in our case, the opposite side in regards to angle 50 is the side length AB all over the adjacent side, which measures 20 units of some sort of length. So now we have to multiply both sides by 20 in order to solve for that missing side length of AB. So we're going to plug into our calculator 20 times tangent of 50 is going to give me the side length AB. So when we plug that into our calculator, we should get approximately the decimal. AB is 23.8351. That's roughly what that decimal is. So now we've found that AB is that. How are we going to find the hypotenuse? Well, think back to the beginning of this unit. What kind of equation or theorem did we use? This is still a right triangle, so you guys, we can still use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. In this case, our c squared is our hypotenuse, and that's what we're solving for. So let's say a is 20 squared plus 23.8351 squared equal to c squared. And I don't need to go through all of the steps. You should be able to figure this out by yourself. We're eventually going to get that c is approximately the decimal 31.1145, and that's going to be our hypotenuse, which is AC. So AC is approximately 31.1145. So make sure you get these two in your notes, and I will see you soon.